You know how it goes. You need to clean up old logs, refresh a materialized view, drop some old partitions. Usually you'd fire up cron on the server or build something in Airflow, but here's the thing. pgcron lets you schedule all of that right inside Postgres. You write the schedule in cron syntax, the job runs as SQL, and you're done.
So it's just cron, but native to Postgres?
Yeah, exactly. And because the jobs are just queries, you can set up logging to check their history and monitor failures, all without needing separate infrastructure. So pgcron is an extension that runs as a background worker. You add it to shared preload libraries, restart Postgres, then run create extension pgcron. The extension creates the cron.job table where your job definitions are stored. The worker wakes up every minute, checks what's due, and fires off the SQL.
Does it run in a separate process or inside the main server?
It spawns background workers that actually connect to the database and run your SQL. They show up in pgstat activity just like any other client connection would. Here's a retention job. First argument is the job name. Second is the cron expression. This one means 2 a.m. every day. Third is the SQL command itself. I'm using dollar quoting here so I don't have to escape the single quotes inside the delete statement.
And that delete runs every night at 2 a.m.?
Yep. The cron.schedule function returns a job ID, and the job definition sits in the cron.job table. You can see all your jobs with select asterisk from cron.job, and you unschedule one by passing the job ID to cron.unschedule. The obvious one is retention. You've got an audit table or an event log, and you want to delete anything older than 90 days. But where pgcron really helps is materialized view refreshes. You can run refresh materialized view concurrently so readers don't get blocked. Just make sure you have a unique index on the materialized view. You can also drop old partitions when you're doing time-based partitioning, or run targeted vacuum jobs on tables where auto vacuum can't keep up.
What about aggregations, like rolling up hourly stats into a summary table?
That's a great use case. Schedule an insert into summary select from your raw table every hour, and you've built a lightweight ETL pipeline without leaving Postgres. Here's where it gets really useful. pgcron does not automatically log job runs to a table. You need to set up your own logging mechanism if you want detailed logs in a table like cron job run details. Once you do, you get start time, end time, status, and return message, which is the actual error text if something failed. So you can query for failures, set up alerts, or even join this table with pgstat statements to track how long your jobs are taking over time.
So I don't need a separate monitoring stack for my cron jobs?
Nope. Once the logging is set up, it's all in the database. You can build a view that flags jobs that haven't run recently or jobs that are consistently slow. It's just SQL. By the way, my DBA's free health check has extension-aware checks for pgcron. It'll flag failing jobs automatically and show you the actual error message from the job run history, so you don't have to remember to query that table yourself. A few things to watch out for. First, jobs run with specific permissions, so double-check your access if you're working across schemas. Second, pgcron has a limited number of worker slots. If a job takes longer than the schedule interval, it'll block the next run. And third, always set a statement timeout inside your job SQL. You don't want a runaway query holding a worker open forever.
Wait, so if I schedule a job every minute, but it takes 2 minutes, the next run just waits?
Yeah, the job won't overlap itself, which is usually what you want, but it means you need to size your schedule interval to match the job's runtime. Or you can adjust the configuration to allow more parallel jobs if your workload supports it. If you're using pgcron or any other Postgres extension, my DBA's free health check will scan your database and flag common issues, including failing cron jobs, missing indexes, bloat, and config problems. You'll get a full report graded across 16 domains with the exact SQL to fix each finding. Connect your database at mydba.dev. It takes a few minutes, and the first report lands right away.